Everybody, this is teacher Yong Lam, and this is the HAL Math mock test number 6 mistakes explanation video. So we can see from over here that in this round of mock test, there are some questions that have some very low accuracy, right? Perhaps because a lot of the students missed out some minor details, right, that are actually very key to solving the problems, right? So this video is dedicated to these questions with 50% accuracy or below. So let's take a look without further ado, right? Starting from the first question, which actually isn't that difficult, right? So let's see. How many whole numbers less than 50 will leave a remainder of 1 when divided by 8, right? So we want to find a whole number. When I divide by 8, it will give me something remainder 1. Now, of course, usually, right, we will start by thinking, okay, what if my quotient is 1, right? So you will think, okay, if something divided by 8 is equal to 1 remainder 1, how do I find this number, right? This number will be 1 times 8, right? My divisor times my quotient, and then add up my remainder, right? 1 times 8 plus 1 equals to 9, right? Indeed, 9 divided by 8 is 1 remainder 1. Now, what happens if I divide by 8 and get 2 remainder 1? Then, likewise, multiply the quotient and the divisor. 2 times 8 plus 1 will be equal to 17, right? So you have 17. All right, so at this point, you will realize you can actually keep continuing to find the next number, right? By following the same pattern, right? Something divided by 8 is 3 remainder 1. So it will be 3 times 8 plus 1 equals 25. Right, so you will get 25. Then if something divided by 8 equals 4 remainder 1, you will use 4 times 8 plus 1, which is equal to 33. Okay, that's another number. Then I divide by 8, I will get 5 remainder 1, right? What if that's the case? Then the number will be 5 times 8 plus 1 equals 41. Right, and if I divide by 8 and get 6 remainder 1, that will be 6 times 8 plus 1 equals 49. Right now, at this point, many of people will stop here, right? Because of course, we want numbers less than 50. So there's no point continuing further after 6. But some of you might have forgotten that my quotient could actually not even be 1, right? It could actually be 0, right? What happens if my dividend is smaller than my divisor? It's entirely possible, and the number that we get is 0 times 8 plus 1, which is equal to 1, right? If you do 1 divided by 8, you won't form a group of 8 items. There will just be 1 remaining item, right? Which is not in the groups. So in total, there are actually 1, 2, 3, 4, 5, 6, 7 numbers less than 50 with a remainder of 1, right, when we divide by 8. So for this question, the key trap over here is realizing that your quotient may not be 1 or above, right? You can have a quotient of 0, right? Then in that case, this means you cannot form a single group of 8. You don't even have enough items for that, right? So hopefully this question will help you, right, identify some misconceptions when it comes to division with remainder. All right, now let's move on to the next question, which is question 22, a quite special page problem, right? Usually for page problems, I'll ask for a number of digits, etc. But over here, Kathy found a book which was missing a certain number of pages. When she opened the book, she saw the number 24 on the left side and the number 45 on the right side. How many sheets between those pages were missing, right? So sheets and pages, these are two concepts that we need to clarify with, right? A page is simply one side of a piece of paper, right? A page is one side of a piece of paper. Whereas if I have the front and back, right, a whole piece of paper, that one I will call it a sheet or a piece, which contains two sides. In other words, two pages, right? So these are some terminologies of page problems that you will need to know, right? Numbers, digits, right? These are what we usually see. And today we look at pages versus sheets, right? To put it in simple terms, a sheet has two pages. So now we need to wonder, what are the missing pages? How many are there? And from that, how many sheets are missing? Kathy saw 24 on the left side. That means 24 is still here on the book. And number 45 is also still here on the book. So where are the missing pages? Right, the missing pages are pages 25 to 44. Okay, how many missing pages are there? Right, so to find the number of missing pages, it is equivalent to finding how many consecutive numbers are there in a range, right? A lot of people might think, I know it's 44 minus 25. But this is actually not correct, right? Don't forget you need to plus 1, right? Just like if you do what? 3 to 6, how many numbers are there, right? So you will think it's 6 minus 3, but that's not correct, right? 6 minus 3 means you are taking away the first 3 numbers out of the 6. But if you want to include the range 3 to 6, you need to bring back the number 3. That's why you need to plus one more number, which represents the original stuff. All right, so that's why there's actually 4 numbers. Similarly, if my range is 25 to 44, I should have 44 minus 25 plus 1, which is 20 missing pages. Right, so you might think the answer is D, but take note, I am asking for the number of missing sheets, and there are 2 pages in one sheet. So to count the number of sheets, I will do 20 divided by 2, which is equal to 10 sheets. So there are 10 missing sheets. If you want to list out, that will be 25 to 26, 27 to 28, 29 to 30. Okay, you can keep on listing. The last sheet will be pages 43 to 44. All right, so hopefully this question is helpful to identify the difference between pages and sheets. Okay, now moving on to the question with the lowest accuracy rate yet. Right, so let's look at this question with quite some concepts to explain and some details that you might miss easily. The table below shows the rates of renting a bicycle at a shop, right? So the longer you rent a bicycle, of course, the more price that you need to pay. Daisy rented 2 bicycles from 3 p.m. to 5:50 p.m. She paid a total of $32 for renting the bicycles. Right, so you look at this rate over here, right? First hour, she pays $8, right? But take note, this $8 is actually the price for renting a bicycle. So everything that happens over here is only for one bicycle, right? Everything that happens over here is only for one bicycle. How much did Daisy have to pay for every additional 30 minutes or part thereof for renting a bicycle? So first things first, we take note the numbers. 32 is the price to rent 2 bicycles. So we need to first find out what is the total price for 1 bicycle. Right, so that one would be simple. You will just take your 2 bicycles, 32, divide by 2, divide by 2. So each bicycle will need to pay $16, right? We need $16 to rent the bicycle for this range of time, 3 p.m. to 5:50 p.m., right? But the structure in which we make the payment might be a bit confusing. So let's read the table again. For the first hour you rent the bicycle, you will need to pay $8. For every additional 30 minutes or part thereof, you need to pay another amount. Now, what does that mean? Another common case of using this payment scheme would be perhaps in your shopping mall car parks, right? So let's say the first hour you park your car, you pay $8. But every additional 30 minutes or part thereof, it will trigger a new payment. So for example, you park for 1 hour, right? Or you rent the bicycle for 1 hour. It will be $8, right? So it will be $8. From that, let's say that you trigger a new cycle, right? You go more than an hour. For up to the next 30 minutes, you will pay another certain amount. Then if you exceed the next 30 minutes, you will pay another such certain amount. Okay, so every new minute beyond the 30 minutes will trigger a new payment. Okay, so let's say after this, you park for what? 2 more minutes. even if you park 2 more minutes beyond the previous 30 minutes, it will already trigger a new round of this certain payment, right? That's the meaning of park thereof, right? Every 30 minutes, we start a new cycle. So now we need to come back to the question and analyze the time range. Okay, so Daisy rented each bicycle from 3 p.m. to 5:50 p.m. Starting from the first hour, right, she needs to pay $8. So that means starting from 3 p.m., if she rents until 4 p.m., like all the way to 4 p.m., that's the first hour of her renting. It will account for the $8. Okay, then every additional 30 minutes or part thereof, she needs to pay an extra amount of, I don't know how much, right? So we have to start from 4 p.m., right? Let's say she exceeds 4 p.m. and she rents for 30 minutes. So 4:30 p.m. Then she will need to pay a certain amount, which you don't know. Then we still exceed the time, right? So from 4:30 p.m. to the next 30 minutes, right? 5 p.m. She will pay again this amount. She still exceeds, right? From 5 p.m. she will continue until 5:30 p.m. This is the next 30-minute block where she will also pay this amount. Now, beyond that, she still continues renting each bicycle, right, from 5:30 p.m., entering to a new 30-minute block, but she didn't finish it, right? She only finished up to 5:50 p.m. Even though that's 20 minutes, but it's part thereof, right? Part of a new 30-minute block. So regardless, she will need to pay this amount again. Now, she rented one bicycle for all this time, and in total, she paid for $16, right? So all of these will total to $16. $8 plus 4 times of this mystery payment is $16. That means the 4 times of this mystery payment will add up to $16 minus $8 equals $8, right? And 4 mystery payments is $8. Each mystery payment will be $8 divided by 4 equals $2, which is why the answer is actually B, right? A lot of you actually chose A because you forgot the key point over here. This table is for renting one bicycle, right? The details is for one bicycle, but the data, $32, is given for 2 bicycles, right? That's why you need to read the question very carefully, right? To try to identify some key details that could be traps if you didn't identify them in time. All right, so that's the multiple choice question that I would like to go through today. Moving on, let's go to our first short answer question, right, which is a number puzzle question. Now, as usual, when you see this, the same shape represents the same number and different shapes represent different numbers, right? We have a 3-digit number, circle, star, flower, plus circle, star equals, plus an extra circle equals 874. And we want to find the value of circle plus star plus flower. Now, there's actually a little hack, which is that circle plus star plus flower is appearing in the ones column. So you know that the ones digit must be 4, right? But what could it be, right? Now, even though this is a hack, it narrows you down to maybe 3 options, right? 4, 14, or 24, right? So let's try to analyze thoroughly to see which answer it actually is. Now, when you are adding 3 numbers, right, in a vertical form, first we need to identify what is the maximum carryover that it could have. Okay, so if it's 3 numbers, I can say 9 plus 9 plus 9 at most, right? That will give me 27. So you know that the carryover is at most 2. This is useful, right? Because sometimes you may have more than 2 numbers added in one go. So whenever you see that, use the largest possible digits to add up and see what's the maximum carryover. Okay, now let's see if this trick is needed in this question. Now, actually, the breakthrough point over here is you have a circle in the tens, circle in the ones, and circle in the hundreds, right? Hundreds, tens, and ones, right? They both have the circle and they represent the same digit. Which digit could it represent? Do you think I can have digit 8 as a result and digit 8 as my circle? Well, actually, that's sort of impossible, right? Because if I were to do that, then regardless of what these digits are, I would already have 800s, 810s, and 8 ones, which adds up to 888, right? So 800 plus 80 plus 8 is already 888, which is bigger than what I have here. So the circle cannot be 8. Then could it be 7? Well, then let's try, right? What if this is 7, 7, 7? Then I will already have 700s, 7 10s, and 7 1s, right? Which means the circles will already contribute to 777, right? So actually, before I proceed, here's a little trick, right? For example, let's say I have 12 plus 34, right? What's the answer? 46, right? Now, what if I shift these two digits within a column? Within the column, I shift the position of these two digits. Then I will get 14 plus 32, right? I just shift the position of the ones within the column. You will realize that the answer is still 46. Likewise, if I shift the two digits, right, I exchange their positions in the tens column, take note, within the same column, that will give me 32 plus 14 equals 46 as well. So shifting or changing the positions of digits within the same column will not change the result of the addition overall, right? This only works for addition. Subtraction cannot. Now, I can actually shift the positions, right? Exchange the positions of these two shapes and then exchange the positions of these three shapes within the column to give me circle, 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 then star, star, flower. Right, so you see the tens column from star circle becomes circle star. The ones column from flower star circle becomes circle star flower. Since I'm just switching within the column, I'm not switching across columns. And since it's addition, when you add them up, that will still give you the same result, 874, right? So with that, perhaps it's clearer to see, right, what is the value of each shape. Now, back to our guess of the circle. Now, it could be clearer now that my circle is 7, as my assumption, will give me 777 as this pretty three-digit number. Now, in that case, maybe it's possible, right? We just need to find suitable values for the star and the flower. But first, let's focus on the star and the flower. Now I know this under my assumption is 777, right? So then 777 plus a two-digit number plus a one-digit number is equal to 874. Then how do I find the sum of these two numbers? Right, that will be these two numbers adding together is 874 minus 777 equals 97. Right, so that means my star plus flower is equal to 97. Now, can you figure out what digits I should choose for my star and flower now? Now, again, we can start by looking at the highest digit. Now, in this case, my highest digit is the tens digit, which is 9. But of course, I cannot choose star to be 9, right? Because 99 is already greater than 97. So I will have to choose the next largest digit, which is 8, right? And have a carryover of 1 in the tens place. So then 88 plus what is 97? That's right, 88 plus 9. Just nice, if you set that, then your sum will be 97, which means originally star is 8, flower is 9, 777 plus 88 plus 9 is 874. Or back to the original, 789 plus 78 plus 7 is also 874. Right, so with that, you can get that. Circle is 7, star is 8, flower is 9, the sum is 24, right? 1 out of 3 chances to get it correct. Now, some of you might think, teacher, the carryover could be 2, right? So, can my circle be, can my circle be 6? Now, that is sort of impossible because if you have 600 and something, then 800 and something minus 666 will actually give you 200 and something, which is impossible to achieve with a two-digit number plus a one-digit number, right? Because 874 minus 666 will be 208, right? And with just a two-digit number plus a one-digit number, you cannot get 200 and something, right? That's why the only possible case is 777 for the circles, 88 for the stars, 9 for the flower, right? And that is question 30 for you. All right. So now let's move on to the next question right after this tricky addition number puzzle. The next question is an interval problem, which again have some minor details that maybe some of you might have missed. Let's read the question. The pupils in class A queued in two rows. If there were 38 pupils in class A and the distance between each pupil was 50 cm, what was the length of one row in meters? Now, some of you might think, Teacher Yonglam, does that mean 38 pupils are all together in one row? No, right. It is in two rows, right? So altogether, the 38 pupils are lined up into two rows. Okay. Now, there is actually a slight detail that was missed out in this question, but I think it's better to point it out, right? The question would be better if I highlight that these two rows are equal. Because who knows, maybe one row is shorter, one row is longer, right? So to clarify, let's just say that this is two equal rows, right? And then there are 38 pupils in total. So how many students will there be in one row? Then two equal rows, there are 38 pupils. Then one equal row, there will be 38 divided by 2, which is 19 pupils. All right, so that means each row will have pupil number 1, followed by pupil number 2, all the way up to pupil number 19. Okay, maybe let me make it clearer. Pupil number 18, pupil number 19. And we are asked, what is the length of one row? Like this, right? Now, take note. Where does the distance come from? Does it come from the pupils itself? Actually not, right? Because the pupils are actually not that wide compared to the interval between the pupils, the gap between them. The distance between two pupils was 50 centimeters, right? 50 centimeters. So we need to find out how many gaps are there, how many intervals are there. Now, since there are objects at both ends, right, we count the length of a row from the end object at one end to the end object on the other end, right? So then there are 19 pupils. How many intervals are there between these 19 pupils? Right? So if you have learned interval problems, you know that there's actually one less interval than your object. If you have an object, or in this case, a pupil at both ends, then that means there are 19 minus 1 equals to 18 intervals. 18 gaps between the pupils, right? Starting from the first to the 19th. Now, 18 intervals, each interval is 50 centimeters. So the total distance is 18 times 50, which is 900 centimeters. But take note, the question is actually asking in terms of meters, right? In meters. So some of you might have keyed in 900 as your answer, but remember, you need to change it to meters. And how many centimeters does 1 meter have? It is 100 centimeters. So if I have 900 centimeters, that will be actually 9 meters, right? So the answer is 9 in this case. All right. Now, this question is not phrased in the best possible way, right? But assuming they are equal, then each row will only have 19 pupils. And the distance is contributed by the intervals, right? And don't forget to change your units of measurement. All right. So that's our interval problem over here. Okay, now let's take a look at the next question. This is question 38, right? It has a very simple question statement. Observe the sequence below. It has how many black and white circles in total? Now, this is actually a question that has multiple knowledge points together, right? We have figure and number patterns. We have perhaps arithmetic sequence. And believe it or not, there's actually interval problems, okay? So let's try to count how many black and white circles are there by first looking at a pattern. Now we started off with one white circle, right? One white circle. Then there are two black circles. Then one white, then four black, then one white, then six black, then one white. Then can you guess how many black circles are there before the next white circle? That's right, there should be eight black circles, then one white circle, so on and so forth. Hopefully by now you could have seen the pattern, right? And then we will meet one white circle after your dot dot dot. And then please count carefully. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 black. Finally, one white. All right. So since it's asking for the total number of black and white circles, let's try to count them separately and then add them up. Now, perhaps the easier pattern to observe is that I always have one white, one white, one white, one white, so on and so forth, right? And at the end, I still have one white. So, every time a white circle appears, it appears as one. But how many one white circles are there, right? That is the key question to ask. And it actually depends on your black circles. Now observe the black circles. The first time it appears, there are two of them, then four of them, then six of them, then eight of them, and so on and so forth. Do you realize that there's a pattern in the number of black circles? That's always plus two, plus two, plus two, all the way to the end where I have 18 black. So the number of black circles in each segment, right, is forming an arithmetic sequence with a common difference of 2. All right, so then we want to find out the total number of black circles, right? That will be 2 plus 4 plus 6 plus 8 plus dot 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 plus until 18, right? This is an arithmetic sequence. To find its sum, you will need three elements, right? The first term, the last term, and how many terms are there. Now, the first term is 2. You need to add with the last term, 18, right? This is sort of like your rainbow method, right? Then multiply by the number of terms, right? Times, how many terms are there? Now, these are all even numbers or multiples of 2, right? So this is 1 times 2, this is 2 times 2, all the way up to 9 times 2. So, of course, there are 9 even numbers, 9 terms. Finally, divide by 2. Right, so that is the formula of your arithmetic sequence, right? Arithmetic sequence is a sequence of numbers with constant increase or decrease from term to term, right? In this case, plus 2, plus 2, plus 2. To calculate the sum, you will need the first term, right? Let me note down the formula to review. The first term plus the last term multiplied by the number of terms, and finally divide by 2. Okay, and that will give you 20 times 9 divided by 2, which is 90. So there are 90 black circles in total. How many white circles are there? Now, you can think about it in two ways, right? Every time I have a term, I pair it with one white, right? I have a term in the arithmetic sequence, I pair it with one white. Pair, 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 right? Now, there are 9 terms in the arithmetic sequence just now, which are your 2, 4, 6, 8 up to 18. Every time I have this term, or in picture terms, every time I have a group of black circles, that means in front there must be a white circles. So up till now, I have found 9 white circles that I can pair it with a group of black circles behind it, right? Pair it, pair it, pair it, so on and so forth. Sorry, I repeat, pair it, pair it, pair it, pair it, right? Maybe this is clearer. And this 9th white ball, I will pair it with the 18 black ones. But don't forget, at the end, I still end with a white circle. So there is another white circle at the very end of the sequence. So in total, there are actually 10 white balls. Now, another way to understanding it is to treat your black balls, right, or your black circles as the intervals between your white balls, right? Treat your white balls as your objects. Then between the white balls, there's a gap. We call that the interval, right? So you actually have 9 groups of black circles. That's 9 intervals, right? So you consider the objects, right, being the white circles. There are actually 9 plus 1 equals to 10 white circles. All right, so altogether, 90 plus 10 is equal to 100 black and white circles in total. Okay, so this question is pretty interesting. It tested on multiple ways of thinking, right? How to calculate the sum. Okay, now this question is over. Now let's move on to the next question, which is a working backwards problem. And it involves more than half, less than half. Now, further details about this, I have gone through in my live stream on working backwards and cyclic problems earlier, right? But let's just read the question. Alex, Benny, and Carl are eating bananas from a basket. The number of bananas Alex has eaten is 2 more than half of the total number of bananas. The number of bananas that Benny has eaten is 10 less than half of the remaining bananas. So from whatever is left, 10 less than half. Carl has eaten 15 bananas and now there are 9 bananas in the basket. That means at the end there's 9. How many bananas are there in the basket at first? Okay, so how do I do this question? Now, first of all, this is a working backwards question because I gave you the ending number and I want to find the number at first, right, at the start. So we have to visualize this either using a bar model or a train diagram, right? So in a very intensive, like time-sensitive exam like GEP or HAL, I would recommend using a train diagram, right? Because bar models, it might take a longer time to draw, right? So then how do I do this using a train diagram? So remember, when we do working backwards, a train diagram is always used to track whatever is left or remaining. So in this case, we want to find out how many bananas are there in the basket at first, right? So we are focusing on the bananas in the basket. So we only focus on what happens to the bananas in the basket from at first to at the end, right? It's always in the basket. So we don't care about what's taken away. Or rather, we don't track what is taken away, right? So now let's start from this starting, right? We draw a box to represent the starting number. Then also remember when you want to draw the train diagram, you always draw forward and remember to follow the order of the story. After you finish the story, you finish drawing forward, then only you calculate backward, right? The moment you reach the end, you can calculate backward, right? So let's see how we do this question. First of all, it's Alex who has eaten the bananas, right? Eaten how much? 2 more than half. Alex has eaten 2 more than half the total number of bananas. So imagine, right? This is the bananas. What does 2 more than half mean? Did he take half? Or did he take 2 first? 2 more than half means initially Alex take away half, right? So this is the part that is taken away. That means the remaining is also half. However, he didn't only take half, right? He took half and then he take 2 more. 2 more than half means whatever he takes is not just here, but also 2 more. So 2 more is gone. That means the remaining is 2 less than half, right? So in other words, Alex will take away half first. When he take away half, the remaining is also half. So to find the half, divide by 2. Okay, then you can draw another box. But then remember, Alex also takes 2 more, right? Take 2 more than half means I take away half and then I take 2 more. I take away half and now I take 2 more. Whenever I take 2 more, the remaining will be fewer, right? So it's 2 fewer for the remaining. Okay, so that is for Alex's path. Now let's take a look at the next person, right? So this one is a bit not symmetrical. Let me change the sizes of the boxes. All right. Now the next person to eat is Benny. Benny has eaten 10 less than half of the remaining bananas. So what does 10 less than half means? So imagine this is the half. Sorry, this is the total, right? And then Benny was about to take half. but did he actually take away the half? No, right? So he actually took 10 less than half. So this is the part that is taken away. This is not clear. This is the part that is taken away. And this is the part that is remaining. So if we focus on the remaining, not only is there still a remaining half, but there is 10 more. So we find the half first, and then take note the remaining, there's extra 10 beyond the half. So when I say take away 10 less than half, you first have half left, right? Then you take away half, so that's half left. But he actually takes 10 less. He actually takes 10 less. So it's as if he puts 10 back into the remaining. It's as if he puts 10 left in the remaining. And yeah, that is the part that Benny has eaten. Now, finally, Carl has eaten 15 bananas. So he take away 15 bananas. So of course, there are 15 less in the remaining. And the final result is 9. All right, so we have finished drawing the train diagram. It's now to work backwards, right? By calculating, and make sure when you calculate, the number stays the same in each step, but you reverse the sign, right? Minus, switch to plus. 9 plus 15 is 24. Plus, switch to minus. 24 minus 10, 14. 14 times 2, right? Divide, switch to multiply. 28. 28 plus 2 is 30. Finally, 30 times 2 is 60. So my answer is 60. Right, there are 60 bananas at first. All right, so this is a working backwards question. Be very careful. What does take away more than half and take away less than half means? All right, now let's take a look at question 48, right, which is our last question of the day. When Aaron was doing an addition problem, he regarded the 9 in the units place as 6 and the 6 in the tens place as 9. And the result was 174. So what could be the correct result? So this is actually a working backwards and forwards sort of question, but we can understand this using the concept of place values and the value of a digit, right? What happens to the number or to the result when we change the identity of a digit, right? So let's say, right, Aaron is actually not that careless and he did everything correctly. If Aaron was correct, he would have gotten a result, right? So the correct actual result, there should be one, which is what we are finding. But we don't know that. It's okay, right? Let's just give it a symbol to represent, okay, it is a certain number. A certain number, maybe it's a 3-digit number, right? Since the result that he calculated is a 3-digit number. Maybe, right? So maybe it's a 3-digit number, but it's okay. We can use a symbol to represent. So this correct result was supposed to be correct. But why did he get to 174? That is because, first, he regarded the 9 in the units place as 6. So the units digit was supposed to be 9, but he read it as 6. So it's like he changes the 9 in the units place of a certain number to 6. How does this affect the value? Units digit 9, the value is 9. It becomes a value of 6 by changing the digit. So the value is actually decreased by how much? 9 minus 6 equals 3, right? That means the first mistake makes the entire value of the sum decrease by 3, right? So for example, 9 plus 1 equals 10. If he mistakes the 9 as a 6, then 6 plus 1 is equal to 7. You see, the result is 3 less. Okay, so that's the first mistake. But then there's also the second mistake. The second mistake is he read the tens digit, which is 6, as 9. He regarded the 6 in the tens place as 9. Does that mean the value increases by 3 this time? No, because this is a mistake at the tens digit. So at the tens place, the value of 6 is 60. He changes to 90. This, of course, causes an increase in the value. by how much? The value increased by 90 minus 60 equals 30. So the second mistake causes an increase in the value of 30. And this will make it 174, right? These two mistakes contribute to a change in the value, which contributes to the result 174. All right, so then what should the correct result be? Now in that case, what should we do? We just need to calculate the value of triangle, which is the correct result, right? So minus 3 plus 30, I can just combine it. Triangle, right? Let me draw a better triangle. Triangle plus 27 is equal to 174. That means the original correct result will be 174 minus 27, which is 147, right? So that is how I get the answer. All right. So yeah, use some understanding in your place values and your values, and then work towards the story and see how does each mistake contribute to a change in the value. All right. So that's it for our explanation today. Hope it has been helpful. And please remember to try out our new mock test that we have posted. All right. I'll see you when I see you again. Goodbye.